Okay. Okay, so let's look at an example. If I have log base 5 of 2t plus log base 5 of t minus 4 equals, that's a minus, t minus 4, equals log base 5 of 48 minus log base 5 of 2. Okay, what I want to do is, obviously I want to solve for the variable. I want to solve for t. So I want to make it log base equals log base. So I want to condense the left side into one log. I want to condense the right side into one log. So we're condensing left side into one log, right side into one log. And we can do that because what do we know? As long as it has the same base, log addition, we can convert down to one log and make it multiplication. So this is log base 5 of, and then I'm going to have 2t times t, the quantity of t minus 4. Is it important that I have the t minus 4 in parentheses? Yes. And then equals log base 5. And now what can I do with log base 5 48 minus log base 5 of 2? How do I condense that? You got it. So this is going to be log base 5 of 48 over 2. Are we good so far? All right, so now I'm going to distribute this in. So we have log base 5 of 2t squared minus 8t equals log base 5 of 24. So I make sure I have the same bases. Log base 5, there's an equal. As long as the logs are the same bases, and they're equal, wouldn't that mean that their arguments have to be equal to each other also? So now I'm going to set their arguments equal. So I'm 2t squared minus 8t equals 24. What am I going to have to do? Set equal to? 0. We're going to have to factor. So we're 2t squared minus 8t minus 24 equals 0. Before I start factoring, what should I pull out? A GCF of 2. So we are t squared minus 4t minus 12 equals 0. So now we factor t minus 6, t plus 2. And now we're going, can 2 ever equal 0? No, so that GCF is out. We'll have t equals 6 and t equals negative 2. We're going to have to check. Because aren't logs exponential equations, and don't we always have to check exponential solutions? So we have to check log equations. Check log equations. All right, so what does that mean? I'm going to go back to my original, our check. So I'm going to have log base 5 of 12 plus log base 5 of 2 equals log base 5 of 48 minus log base 5 of 2. All right, so let's check the negative 2. Let's check t equals negative 2 first. So where are my variables? What did I do? Oh, I plugged in the 6 first. I plugged in the 6 here. All right. When I plugged in the 6 for t, this ended up working out, right? So we're going to have log base 5 of 24 equals log base 5 of 24. Do we agree? The t works out. Now let's check the negative 2. All right, when I check the negative 2, I have log base 5 of negative 4. Am I allowed to have that? No, that doesn't work out here. This doesn't work out. So right away, I know this is undefined. So we reject t equals negative 2.
Look into the original.
The original. Always plug back into the original. Always plug back into the original, guys. Always plug back into the original. All right, let's do another one. You guys try this one on your own. 2 log base 3 of t equals log base 3 of 2 plus log base 3 of the quantity of t plus 12. You guys simplify that one, or you guys solve that one on your own.
No, it does work.
Like there?
Wait, you can't.
More?
Because it's square.
Do 2 log of 3 negative.
Oh, did you get it?
Yeah,
I got it.
What'd you get?
6 and -4.
Yeah, but which one? Negative 4.
Checks out.
Both work.
Yep, I do that.
Good job. You thought
Because if
negative
you
four-
put it,
you thought
if you
negative
put
four
it
didn't work.
2 log of 3 to t, it's just negative 4 squared, which is 16.
Yeah.
So it works regardless.
Yes, it does.
How?
Put the exponent back in.
If it's 2
Okay,
yeah,
but
but
it's
2
still an
log
exponent.
of 3 to t, that's just saying negative 4 squared.
Yeah.
Which is 16.
Exactly. Come on, man.
They both work.
Don't know what I did.
It's
It's not about original.
Think.
Write this right.
How do you get to 50? Yeah, how'd you get to 6? When was 2 times 12 15?
Think about it.
Wait, are you having some trouble?
I need 24 fingers.
I think you
That's
choose
the
your
problem.
fingers.
Yeah.
Oh wait, but it doesn't work over here.
Yeah.
It works.
So, would you get structure on that?
Is it? What'd you get? Did you get 100? 80? Above a 90? Nah, already.
He got below
no.
90. He got a 76. He got a
76 is a great
What did you get, bro? What'd you get?
Bro, 76 is a great number. Don't be ashamed of it.
76 is like every
76.
All right, are we ready, guys? Okay, so what do you think I did first? What do you think I did first? The 2. What did I do with the 2? Log base 3 of t squared. All right, what about the other side? What did you do there? Multiplication. Multiplication, and within that argument, what do I have to do? Distribute. So this is 2t plus 24. Do we agree? So now I have log base 3 of an argument equals log base 3 of an argument. What should I do? Set the arguments equal. So now we have t squared equals 2t plus 24. What are we going to have to do? Make it equal to 0. So we can factor. All right. When we factor, we get t equals 6 and t equals -4.
It works because it's 2 log of 3 to t.
What was one of our main rules about arguments? What was one of our main rules about arguments? Our arguments cannot be what? Negative. Our argument cannot be negative, because if you raise a negative argument to a fractional exponent, then we end up with imaginary. So we never want to allow our arguments to be negative. So we are rejecting the -4, and the 6 works.
But it's 2 log.
I know, but it's just a general rule that our arguments are never negative. Our argument can never be negative.
So you don't have to test. You can't.
When would having a negative is fine?
Shut up, man.
If when you plug it into the argument, it's not 0. So let's say like I got a negative, but let's say it was log of 3 and then it was t plus 5. And then I got t equals -1. Well, that still makes the argument positive, so I'm fine with that negative t. Does that make sense? Okay. All right, let's keep going, guys. Now, remember, yes?
If it's negative, you don't have to test.
Well, you do, because look, I just gave Draven an example. Let's say it was log base 3 of t plus 5, and now when I plugged in that -1, it'd still be a positive argument, so I would have to test. Yes. Guys, I keep getting the same question over and over again because you're all talking and not listening. So you need to stop. When I get questions, it does not mean it's a free-for-all for everybody else. What's up, Aditya?
If it was log base 3t squared, then would it be okay to have like the negative?
T squared, like the t in the parentheses from the beginning, yeah. Okay, we good? Okay. So now I said there's two scenarios for log equations, right? The easier scenario is when one log equals another log. But there's another scenario. The second log equation scenario, second log equation scenario, is when a log equals a number. Can I show you? Okay, so let's say I have log base 4 of x minus 1, the quantity of x minus 1, plus log base 4 of x equals 1. Write it down and then we'll pay attention. So, if what you're saying is what I think you mean, then yes. So what I'm going to do is I'm going to condense the left side. When I condense the left side, I'm going to have log base 4 of x squared minus x, right? I made the log addition down to 1 log and multiplied the arguments. Are we okay with that so far? Okay, the biggest mistake now is that people treat this as a log equals log. So they say x squared minus x equals 1. That's not the scenario. Is the 1 written as log base 4 of 1? No. So what we're going to do now is actually change this back into exponential. What do I mean when I say change this back into exponential? Let me write it down. Change back into exponential. So what do I mean? Remember, it's log, base, answer, equals exponent. So now if I'm changing it back into exponential, my base is 4. What's my exponent? 1. What does that equal? X squared minus x. So now we're going to have to factor. So I'm going to subtract that 4 over. Yeah, there are no factors of -4 that add to -1. So we will have to use the quadratic. So now we have x is equal to -b plus or minus the root of b squared minus 4ac all over 2a. So we're going to have 1 plus or minus 1 plus, plus 4, right? 6c, yep, 4ac is 16, all over 2. So we're going to have x is equal to 1 plus or minus the root of 17 all over 2.
We just leave it like that as an answer.
Well, there's two answers here. Are they both acceptable answers?
No.
No, because if it's 1 minus the root of 17, isn't the root of 17 bigger than 1? Right? So isn't that going to yield us a negative? And then when I go back, I'm going to look back to the original. All right, I have x as just an argument. Can I have a negative argument? No. So for that reason, what am I doing? Rejecting the negative. X equals 1 plus root 17 over 2. All right, you all try this next one on your own. Yep, one more problem after this and then we're done. Log base 2 of y plus 4 equals log base 2 of y. Oh, sorry, not equals, sorry, plus. Log base 2 of y equals 5.
Bro, I'm still doing the math. It's 32, by the way. Trying to do equal.
Reject negative 8, keep 4, minus 4.
Did you get 2?
I got 4 minutes.
I got 4 too. I got 4.
Which one is rejected?
Are we ready? I guess we have answers. So we get y equals 4 or y equals negative 8. But what should we do with that negative 8? Reject it. So it's just y equals 4. Who needs to see me do it?
On a test, do we have to write reject or just write?
No. Just y equals 4 is fine. All right, last one. You ready? You guys do this one.
Alright, let's go.
You want to try it on your own, and then I might have to go over it.
That's fine.
Is this the last problem?
This is the last problem.
So this is the hardest
Do we
situation.
do the long division? No, because then maybe you could
Oh, no.
you can't cancel. You could cancel. No, you can't.
Well, you can factor.
You can
So your homework is a worksheet. There's 18 problems, but maybe I'll just have you do the odds.
Every other.
Y'all just keep grabbing more. Like I say odds, you try to get more out of me.
Odd multiples. Yeah, please. We just had so much homework.
I hope you all get DiBartolo next year. She's a fabulous teacher. Like I hope it for multiple reasons, but she won't trim the homework down like I do.
Who's the other teacher?
Wait, there's no way to divide this thing evenly.
Who's the other teacher?
Kirschoffer?
I'm doing long division. I'm not doing wrong, but it is.
Huh? You don't need to do long division. You do not need to do long division. All right.
Wait.
Give you a chance.
Wait.
But you're all are yelling at me. You do not need to do long division, children. It is not a difference of you all are really overcomplicating this.
I got it. Wait. I think I got something.
Simon got it. 10 and 15. Is that right?
Wait, let me think.
Simon got it.
It's not that deep.
You're saving the day, Simon?
It's not that deep.
No, it's that.
Okay.
Wait.
Simon got it. Come on. It's better. He got it.
Is this how you?
The bell's going to ring. We have to go over this. So what I'm going to do is I'm going to condense the left side down to I'm condensing the left side down to 1 log. So y squared plus 2y plus 5 over y minus 5. I'm not dividing this. Equals 2. At this point, I'm going to put it into exponential. When I put it into exponential, it's 5 to the second power equals y squared plus 2y plus 5 over y minus 5. So what do I do now? 5 squared is 25. So now I'm going to cross multiply this. So we're going to have 25 times the quantity of y minus 5 equals y squared plus 2y plus 5. So now I distribute in 25y minus 125 equals y squared plus 2y plus 5. And what am I going to have to do now? Set it equal to 0 so I can factor. So we're y squared minus 23y plus 130 equals 0. So we are at y minus 10, y minus 13, no, yes, equals 0. Yeah.
Oh wait, I did.
Y equals 10, y equals 13. I believe they both work. All right, we're done.
No way, Claudia, you got it?